So in this video, we're going to solve system of equations again, but using a different method, which is Gaussian elimination. So basically, it is an elimination method, but for the Gaussian method, we're dealing with matrix to solve the system of equation. Okay? So first, some concepts. So what is Gaussian elimination method? Yeah. It is use an augmented matrix to solve system of equations and transforms the matrix by manipulating the numbers in each row until the elements below the diagonal equal to 0. Okay, so let's look at the example to see what augmented matrix mean and what diagonal mean. Okay? So first here you see you have a system of 3 linear equations and you're gonna make a matrix from them. And that matrix is called augmented matrix. So what you're gonna do, you just need to pick out the numbers in front of the variables and the constant on the other side, and they make up a matrix which is augmented matrix. Okay? So first check your 3 equations. Make sure you have the same order. X, first column X, second column variable Y, third column variable Z. If you have a missing column, you put a 0 there to take the place of that variable. Okay? It's 0Y, and 0 times Y is 0, and for 0 we don't need to write it down, but you need to have a 0 to hold the place. Okay? And then pick out the numbers and make a augmented matrix. So for the first equation, imaginary 1, -4, +3, on the other side 5. So we have the first row for the first equation. Okay? And the second equation, negative imaginary 1, -3, -1, -3 on the other side. Okay? Last equation, 2, 0, -4, 6. Okay, so when you take out the numbers in front of the variables for each of the equation, they make up an augmented matrix. Okay, so in the future, if I give you a system of equation and ask you about the augmented matrix, first you make sure the variables are on the same column, and then take out the numbers in the front and put them together. Okay, and we have another concept here, which is the diagonal. Okay? So what is the diagonal in the augmented matrix? You don't look at the constant part. Okay? You just look at the coefficient part. You don't look at the equal sign and the other part, right? So diagonal is just the diagonal on the left side. Okay? And here in the concept it says what? Until the elements below the diagonal equal to 0. So to solve the system of equation using this matrix method, we need to find the diagonal and make sure you're going to manipulate the numbers inside until all of them become 0. Then you can solve the problem. We're going to see a two system of matrix, a system of equations today. Okay, and one last thing. Some of you say, hey, I take out the numbers and where are my variables go? Okay. Just remember your variables are each of the column. Okay. So the first column is variable x, second column is for variable y, last column is for variable z. Okay, so you see for the first equation, 1x minus 4y plus 3z equals 5. Is it the same? 1x minus 4y plus 3z equals 5. Okay, so just remember, each of the column represents one variable. Okay, so here we just transform the system of equation with variables into the matrix without variable and the equal sign. And this matrix is called augmented matrix. Okay, and second, you can do some calculation or manipulating the numbers in the matrix. So how are you going to manipulate it? You can multiply any number to the entire row or to the entire equation to augment or reduce your equation. Okay, so let's look at this example. So here you have your original augmented matrix, and if you wanna multiply the first row or the first equation by 1/2, you can do it, but just remember, you're gonna multiply each of the elements in the first row. So you're gonna enlarge your first row or enlarge your first equation at the same time. Okay? So you're not changing it. So if we multiply the first row by 1/2, so let's do it. 1/2 times 2 give you 1, so you have 1. Okay? 1/2 times -4 give you -2. 1/2 times 6 give you 3. Last, 1/2 times -2 give you -1. So in this way, you change the numbers in the first row, but actually you didn't change the equation because you enlarge each of the you reduce each of the number at the same time. But you get what's the number you want. Okay, this is one of the manipulation with the numbers inside of the matrix. Let's look at another example. Let's see what this means. Okay, so here your original augmented matrix look like this. Okay, and you want to multiply a -2 to the first row, and whatever you get here for the first row, you want to add up it with the third row. Okay, and rewrite the third row. So let's do the transformation or the manipulation here. Okay, so first you're going to multiply the first row with -2. Okay, -2 times 1 give you a -2. Here you just see the result, but we have a middle step that we skipped. Okay, so let's write the middle step down. -2 times 1 give you -2. -2 times 2 give you -4. -2 times -4 give you +8. -2 times 3 give you -6. So this is a new first row after multiplying -2. And then we're going to add the new row to row 3 and rewrite. The arrow means you're going to rewrite the third row. Okay, so add up the new first row to the old third row to get your new third row. Okay, so let's add them up. 2 plus -2 plus 2 give you 0. So your new third row first element is 0. -4 add 1 give you -3. 8 add 5 give you 13. -6 add -2 give you -8. Okay? So this is your new third row after the transformation or manipulation of the numbers in the first row, then add up the old third row. We have the new third row. And some of you see in the new matrix, the first row is not changing. It's not -2, -4, 8, -6. It's still the old one, right? Why is it that way? Because in the manipulation here, it only say do the transformation and then change the third row. It didn't say change the first row. So the first row is still the old numbers. Okay. So here, both of the slides told us you can multiply the entire row by a number and then add each of the rows. Add between the rows and you can get the new row in the matrix. Okay, now let's use it to solve the problem. Here, let's try with a 2 by 2 system of the equation. Okay, so here is your augmented matrix. And by looking at this augmented matrix, you should be able to write down the original equation. So let's look at the original equation if you're not used to look at the matrix. So we know the first column is variable x, second column is variable y, equal sign, and the other side, right? So the first equation is 1x minus 2y equals 8. Second equation is 3x plus 2y equals 0. Y plus, because it's positive 2, right? So it's 3x plus 2y equals 0. Okay? So these are the original equations. When you take out the numbers in front of the x and the y, you have the augmented matrix. Okay, so here I just give you the augmented matrix and ask you to solve the equation for x and y. So what we're gonna do? We know the goal is just to make the number under the diagonal. This is a diagonal. Make the number under the diagonal to become 0. How can we make the 3 become a 0 by manipulating the numbers here? How do we do that? Okay. We know if the first element become -3, then add up the two equations, two numbers, -3 plus 3, this becomes 0. However, right now it is a 1, so can we turn the 1 into -3? Yes, you can. You can multiply -3 by 1. But remember, when you multiply a number, you multiply the number to the entire equation, to the entire row. Okay? So that is why the first step here is multiply -3 to the entire row. And then add the new first row to the second row. You get a 0 here. So that is the manipulation here. Okay? So multiply -3 to the first row, then add up the second row, and the arrow means you're gonna rewrite the second row to get your new matrix. So let's do it. Okay. First, multiply -3 to first row. So -3 times 1 is -3. -3 times -2 is 6. On the other side, -3 times 8 is -24. Okay? This is the middle step that we skipped, right? And then add the row to to second row. So -3 add 3 give you 0. So and rewrite the second row, right? So rewrite the second row here. -3 plus 3 is 0. Here, right? 6 plus 2 is 8. Here. -24 plus 0 is -24. Okay? So we finished the manipulation here. Okay? And what about the first row? It didn't ask you to rewrite the first row, so you still keep the original numbers there. Okay, so now you have this new matrix, and we have our goal already, which is to turn the numbers under the diagonal into 0. Okay, so until you have this new matrix with a 0 under the diagonal, you almost finish. Why? So let's look at the new matrix. We know the first column is x, second column is y, equal sign here, right? And you see what? You see your second row here only have one variable, which is 8y. So with one variable, we can solve it. So let's write it back for the second row or second equation, which is 0. You don't need to care about it, right? So it's 8, and the corresponding variable is y. So 8y equals -24. And solve the equation for y by getting rid of the 8 by division. So we have y equals -3. Okay? If we know y equals -3, plug it back into the first row or the first equation. You can solve for x, right? First equation is 1x minus 2y. We know y is -3, so it's 2 times -3 equals 8. And keep solving it. First, get rid of the parentheses by multiplying. It's +6. So x plus 6 equals 8. Get rid of the 6 by subtraction. So I have x equals -4. And that's it. Okay? So x equals -4, y equals -3. How are you going to check your answer? Plug -4 and -3 to the place of x and y and see if it's going to make the original equation true. So let's plug it in the second equation. First equation must be true because -4 comes from the first equation. Right? So, did I do anything wrong? Let's plug it in and check. Okay. X equals -4. Y equals -3. I got something wrong here. Let's solve the equation. Here, here is equals 8. I copied equals 2. Equals 8. So 8 subtract 6 is 2. So x equals 2. Okay, and let's check it. 3 times 2 is 6. 2 times -3 is -6. 6 minus 6 equals 0. So it makes both of the equations true. It means our solution is right. Okay, so this method is very similar to solving the system of equation by elimination, but this time we're using the elimination method in the matrix. Okay. Let's look at one more example. Let's look at examples. First one, write an augmented matrix from the system. So just need to make sure each column have the same variable and then take out the numbers in front. So here you see what? X, Y, they're not in the same order. So first you need to change them into the same order. First column is X, second column is Y. Okay. So the second equation just needs to switch the place of X and Y. So you have +4X, +3Y equals 11. And this is, the old one is gone. Now you can take out the numbers. So first equation, 168, 168. Second equation, 4311, 4311. So B is right. Okay? Just be careful. Each of the column has to represent one variable. If they're not, switch the places until you get that. Okay. Next one. Write the augmented matrix. Okay. Again, check each of the column. First column X, no problem. Second column Y, no problem. Last column Z, no problem. So we don't need to switch any place. Just take out the the numbers in front of the variables. Okay? So first equation, 1, 1, negative 1, 3. Second, 2, 1, negative 1, 4. Okay. Last, 2, 2, 1, 12. So B is right. Okay. Just be careful, don't miss any negative signs, and if you don't see a number, it's the imaginary one. Now let's solve. Let's look at which one. Okay, let's look at this one. So here use the row echelon form. It means what? It means this is the last step matrix. Why? So look at the matrix at the beginning. Diagonal. Under the diagonal, you already have a 0, which is what you want. So you don't need to manipulate any numbers. You just solve the equation. How are you going to do that? First column variable x, second column variable y equals sign on the other side, right? And for the second equation, you only have variable y. So 1y equals 7. So y equals 7. You don't need to even solve it, right? And when you know y equals 7, plug it back into the first equation. But what is your first equation? It is 1x positive 2y equals 16. So 1x positive 2y equals 16. And you already know y equals 7. So plug 7 to the place of y. And keep solving this equation. 2 times 7 is 14. Because x plus 14 equals 16. And get rid of the 14 by subtraction. So you have x equals 2. And that's it. Okay. Next one. So for this one, you already have the last step matrix. So this is a diagonal. Under the diagonal, you already have the 0. So you just need to do the last step, solve for equation x and y. So x column, y column equals sign. Okay. So second row tells you 1y equals 1. So y equals 1. One solution. And plug it back into the first equation, which is x plus 6y equals 8. And plug 1 to the place of y. 6 times 1 is 6. So x plus 6 equals 8. X equals 2. And that's it. Okay. Next example. So here you have system of equations. Let's solve it step by step. Okay. So first you're going to write down the augmented matrix. X column, Y column, no problem. So just take out the numbers. It's 2, 2. On the other side is -4. 6, -2. On the other side is 12. So you have the augmented matrix. And then your goal is to make the number under the diagonal to be a 0. I want this to be a 0. How can you make it 0? We know if the top number is -6. So -6 plus 6 is 0. But how can we make 2 become -6? You multiply 2 by -3. So multiply 2 or multiply the entire first row by -3. Okay? So here the manipulation is -3 times first row and then add up with the second row, so you have 0 here in the second row. Right? So add up the second row and rewrite the second row. Why do we rewrite the second row? Because we want to change the 6 into 0 in the second row, so we're going to rewrite the second row. Okay? So here is the manipulation, and let's do the manipulations with the numbers. Okay? First, let's make the middle step on the top here. So negative 3 times 2 is negative 6. Negative 3 times 2 is negative 6. Negative 3 times negative 4 is 12. So this is your first new row, so we finish this part, right? And then add it up with the second row and rewrite the second row. So let's do the rewriting. Second row here, right? Negative 6 add 6 is 0. Negative 6 add negative 2 is negative 8. 12 add 12 is 0. 12 add 12 is 24. Right? So I finish rewriting the second row and doing the addition. Right? And for your first row, in your manipulation, you didn't say rewrite first row, so you copy the old first row, which is 2, 2, negative 4. Okay. If you copy the new first row, it is okay, but your solving of the equation is going to have bigger numbers. Okay. And now you check it. So under the diagonal, you have the 0 you want. So you can keep solving this equation. First column is x, y equals sign on the other side, right? So the second row tells you negative 8y equals 24. So write it down. Negative 8y equals 24. Keep solving it. Y equals negative 3. You divide negative 8, right? And if we know y equals negative 3, plug it back into the first equation. But what is your first equation? It is 2x plus 2y equals negative 4. Plug negative 3 to the place of y and solve it. I'm not going to solve it step by step. So this is negative 6 and plus this is negative 6 and add 6 on both sides. It becomes 2. 2 divided by 2 is 1. X equals 1. And that's it, which is option C. Right. Last example. Okay. Yeah. Here you'll just have an augmented matrix and solve this. So first you have to know where is your variable x and y, right? X, y equals 1, right? And how are you gonna solve it? Just turn the number under the diagonal into 0. So I want this to be a 0. How can you make it into a 0? Okay. Can you turn 2 into 3 and add them up? It seems it's not that easy, right? So what are you gonna do? Okay. So you can do what? You can multiply 2 by negative 3. And then negative 3 times 2 is negative 6, right? And let's write it down. And you can multiply negative 3 by 2. 2 times negative 3 is negative 6. Let me see. Let's we can sorry. We can multiply 2 by positive 3. So 3 times 2 is 6. It's just 6, right? And we can multiply negative 3 by 2, which gives you negative 6. And positive 6 plus negative 6, you have a 0 here. So here we're going to we're going to enlarge both of the equations so that we can cancel the first variable. Okay, so let's do it. What is it? So you're going to multiply the first row by 3 and then add up. You're going to multiply the second row by 2 and then rewrite the second row. So here has more calculations. Okay? So let's do it. 3 times first row. So 3 times 2 is 6. 3 times negative 3 is negative 9. 3 times 7 is 21. And 2 times second row. 2 times negative 3 is negative 6. 2 times 1 is 2. 2 times negative 7 is negative 14. Okay. And then add up the two new rows and rewrite the second row. So let's do it. Rewrite your second row, right? So add up the two new rows. 6 plus negative 6 is 0. Negative 9 plus 2 is negative 7. 21 plus negative 4 is negative 14 is 7. Okay. And it didn't ask you to rewrite the first row, so you just copy the old first row, which is 2, negative 3, 7. Okay. And now you see what? You see under the diagonal, you have the 0. Okay. So now you can solve the equation. First column is your x, second is y equals 9. So for the second row, you have negative 7y equals 7. So y equals negative 1. And plug it back into the first equation, which is 2x minus 3y equals 7. Plug negative 1 to the place of y and solve it. We have, I'm not going to solve it. I have y equals 2. Right? So x equals 2, y equals negative 1, which is option B. And that's it. Okay. Some of you say, solving the system using the matrix is not easier than if I just do the elimination. Yes, if you just have system of 2 equations, you cannot see the advantage. But if you have system of 3, 4, 5 equations, using the matrix is quicker. And hopefully next time we're gonna learn to solve the system of 3 equations. Okay.